What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 11, Section 4, Partial Fractions. Let's do it. Can any quotient of polynomials be decomposed into at least two partial fractions? If so, explain why. If not, give an example of such a fraction. So the answer is no, and what they give in the back of the book is 1 over x squared plus 1. And the reason why this cannot be decomposed is because this is not factorable, right? A sum of squares is not factorable, as we know. So that would be the example done. Explain how to verify a partial fraction decomposition graphically, okay? So what you might have is, let's say you have the original fraction, and then you have the decomposed version, right? And if you graph the original in Desmos and then the decomposed, and if the two graphs match, then you know it's correct. So that's how you do it. Once you have a system of equations generated by the partial fraction decomposition, can you explain another method to solve it? For example, if you had this, we eventually simplified to this. Explain how you could intelligently choose an x value that will eliminate either a or b. Okay. So for example, let's say now we're at this equation here. And in this scenario, right, let's say we want to get rid of b. The easy thing to do is choose x equals -1, because -1 plus 1 is 0, and that's gone. And then you'd have -1 times 3 plus 5, and then you could easily solve for a, right? You plug it in here. Likewise, we could plug in x equals -5/3, right? That would cancel out the a, and then we could solve for b. So that's how you could do it. Done. So for this one, the way we start is we see if that denominator is factorable, and it indeed is factorable, right? What two numbers multiply to -24 add to -5? That's going to be -8 and +3, right? So that's how we factor it. If you want to verify that, you can FOIL it out, and you'll see we get this. Okay, now we can do the fraction decomposition. So this is going to equal a over x minus 8, the first binomial, plus b over that second binomial, x plus 3, like so. Okay, so now we know this is true. Now what I'm going to do is I'm going to multiply everything by this entire denominator, right? The reason why is because obviously if I multiply this by its denominator, it just gets rid of the denominator, right? And then when I multiply it over here, right, I've got x minus 8 times x plus 3. What's going to happen? These are going to cancel out, and I'm going to have a times x plus 3. When I multiply this against this, the x plus 3s are going to cancel out, and we've got plus b times x minus 8. Okay, now we got this great equation. Now we can plug and chug values for x to solve for a and b. So what I'm going to first do is I'm going to plug in -3 for x. The reason why is because that's going to zero this out. And then here we have -3 minus 8 is -11b is equal to 3 times -3, which is -9 minus 79. -9 minus 79 is -88 equals -11b divided by -11, b equals 8. Great, now we need to solve for a. So we come back to this equation. I'm going to plug in 8 for x, right? Because that's going to zero this out. Then we have 8 plus 3, which is 11. So we have 11a is equal to, plug in 8 here, that's 24. 24 minus 79, that's -55. Divide both sides by 11, and we get a is equal to -5. Okay, so now we have a, we have b. Now we can rewrite it using this kind of setup here. And our partial fraction decomposition would be a, which is -5 over x minus 8, plus b, which is 8 over that x plus 3. And that is how you do it. Done. So for this one, again, we're going to start by factoring that denominator. So we got 10x plus 47 over, and what two numbers multiply to 10 add to 7? That would be +5 and +2. And on the other side, we're going to write the fraction decomposition where we don't know what a is, but we're going to put it over the first binomial. We don't know what b is, but we're going to put it over the second one, and then we're going to solve. Okay, now the first step is to multiply both sides by this full denominator, right, which is x plus 5 times x plus 2, right? I'm multiplying everything by this. So that's going to cancel out the denominator here and give us 10x plus 47. Over here, when we multiply this, the x plus 5s are going to cancel out, right? Like that and like that. And then you're going to get equal to a times x plus 2. For the b, the x plus 2s are going to cancel out, and you're going to get b times x plus 5. Now we're going to plug and chug, and first I'm going to plug in -2 for x, and the reason why is because -2 plus 2 is 0, so that's going to kill the a. And then we have -2 plus 5, which is 3, so we got 3b is equal to negative 2 times 10, which is negative 20, plus 47 is 27. Divide both sides by 3, and we get b is equal to 9. Next, we're going to reset this equation, and instead, I'm going to try to zero out this expression by plugging in negative 5. So this is going to go to 0. Plug in negative 5. Negative 5 plus 2 is negative 3, so we have negative 3a is equal to, and then negative 5 times 10 is negative 50, plus 47 is negative 3. Divide both sides by negative 3, and we get a equals 1. Okay, now we rewrite these fractions with those values for a and b. So we have 1 over x plus 5 plus 9 over x plus 2. And that is how you do it. So for this one, we're going to start by factoring the denominator. Now, it's not a leading coefficient of 1, so we're going to have to do a little star method with a, b, and c, putting the a here, which is 20, the b, negative 13 down here, and then a times c, 20 times 2, which is 40 up top. And then we say, what two numbers multiply to positive 40 add to negative 13? That's going to be negative 5 and negative 8. Now we simplify these like fractions, divide by 4 here, we get 5 over negative 2. And then here we divide by 5 and we get 4 over negative 1, right? And those are going to be the coefficient of the x and the constant, coefficient of the x and the constant. Let's write that out. So there we have it. And then this is equal to a over the first binomial, 4x minus 1, plus b over the second binomial, 5x minus 2. Now we're going to multiply everything by 4x minus 1 times 5x minus 2. And when we multiply everything, right, this entire denominator is going to cancel out. So we get 32x minus 11. Over here with the a, these are going to cancel out, and you get a times 5x minus 2. And then when this multiplies against the b, these are going to get cancel out, and you have b times 4x minus 1. Okay, now we're going to choose nice values of x to solve for a and b. So for this one, to zero out the a, to cancel it out, I'm going to choose x is equal to 2/5, right? Because 2/5 times 5 is 2, minus 2 is 0. That's going to cancel that out. Plug it in here. 2/5 times 4 is 8/5 minus 1 times b is equal to, and then 2/5 times 32, that's 64 over 5 minus 11. 8/5 minus 1, which is 5/5, is 3/5. Okay, so we have 3/5 b is equal to, this I can make 55 over 5, so we get a nice common denominator, right? 11 times 5 is 55. So then 64 minus 55 is 9/5, okay? Multiply both sides by 5, get rid of that. 9 equals 3b, divide by 3, and b equals 3. Okay, now we're going to solve for a, and what I'm going to do for this one is I'm going to choose a different value of x to zero out the b, right? And what I'm going to choose is 1/4, right? Because 1/4 times 4 is 1, minus 1 is 0, so that's going to cancel this out. And then we plug and chug here. So first of all, on the left side, 1/4 times 32 is 8, minus 11 is negative 3, is equal to a times 1/4 times 5, which is 5/4 minus 2. By the way, I'm going to make that 8/4, right? Just a common denominator. Then we have negative 3 is equal to 5 minus 8 is negative 3/4 a. Then I'm going to multiply both sides by the reciprocal of this, which is negative 4/3, right? That's going to cancel this out. Negative 4/3 times negative 3. These are going to cancel out. Negatives are going to go away, and we're left with 4 is equal to a. So we got 4 is equal to a, b is equal to 3. So now our final answer is, we're going to come back to this and rewrite it. We got 4, which is a, over 4x minus 1, plus 3, which is b, over 5x minus 2. So there is your final answer. Done. So for this one, we're going to start by factoring that denominator, which is a difference of squares. So we got x minus 3 times x plus 3. And we're going to set this equal to that nice decomposition, a over the first binomial plus b over the second. Okay, let's figure out what these are. Now what we're going to do is we're going to multiply both sides by this denominator, which is x minus 3 times x plus 3. Now, of course, when we multiply the left side, it's going to cancel this out. We're left with 5x. On the right-hand side, when we multiply it against this guy, it's going to cancel out those. So we're just going to have a times x plus 3. And then when it multiplies the second one, right, the x plus 3s are going to cancel out, boom, boom, and we got plus b times x minus 3. Okay, now to solve for a and b, we're going to choose nice values of x. I'm going to start with negative 3 because that's going to plug in here and zero that out. Negative 3 minus 3 is negative 6b. And then negative 3 times 5 is negative 15. Divide both sides by negative 6, and b equals 15 over 6, which reduces to 5 over 2, right? Divide top and bottom by 3. Now we're going to come back to this equation, and instead of negative 3, we're going to plug in positive 3. That's going to zero this out, and then 3 plus 3 is 6. So we got 6a is equal to 5 times 3, which is 15. So similar, right? Again, when we divide by 6, we get 15 over 6, which if you divide top and bottom by 3, you get 5 over 2 again. So look at that, a and b are the same. Now let's put them back into this basic equation, right? So if a is 5 over 2, right? The way I can write this, let's do it down here. I can say 5 over 2, and then 2 just goes in on the denominator, right? 5 over 2 times that x minus 3. And then plus, again, b is 5 over 2. So again, it's going to be 5 over 2 times x plus 3. So this is your final answer. Boom, done. So for this one, we're going to start by factoring the denominator, and that's going to be a difference of squares, x minus 2 times x plus 2, like so. That's going to equal a over the first binomial plus b over the second. Okay, now we're going to multiply both sides by x minus 2 times x plus 2, which is this denominator here. And the cool thing is when I multiply the left side by that, it's going to cancel out the denominator. We're left with 6x. When I multiply the right side first against this term, these are going to cancel out. So I get a times x plus 2. And then when I multiply this term, right, these are going to cancel out, and I get b times x minus 2. Now I'm going to choose values of x that are going to make it easy to solve for a and b. So first I'm going to try negative 2, plug it in here, that's going to zero it out. That's what we want. And then here, negative 2 times minus 2 is negative 4. So we get negative 4b is equal to negative 2 times 6, which is negative 12. Divide both sides by negative 4, and we get b is equal to 3. Over here, now we're going to reset this equation, and now we're going to plug in positive 2, because now I'm going to zero out this term, right? 2 minus 2 is 0. 2 plus 2 is 4, so 4a is equal to 2 times 6, which is 12. Divided by 4, and a is equal to 3 as well. So we have the same value for a and b. Our final answer is now going to be 3 over, right, that's a, x minus 2 plus b, which is again 3, over x plus 2. And that is how you do it. Done. So for this one, we're going to start once again by seeing if we can factor that denominator, which we can, right? What two numbers multiply to negative 6 and add to negative 1? That is going to be negative 3 and positive 2. Okay, negative 3 plus 2 is negative 1. Cool. And this equals a over that first binomial plus b over the second, x plus 2. Okay. By the way, the ordering is arbitrary, right? I could have switch these around. It doesn't matter. Now we're going to multiply by this denominator here against both sides. So we're going to multiply everything by x minus 3 times x plus 2. Now, when I multiply the left side, of course, it's going to cancel out the denominator. We're left with 4x minus 1. When I multiply the right side, first when I multiply against this term, these are going to cancel out. And then we have a times x plus 2. When I multiply it against this term, right, the x plus 2's are going to cancel out. So then we have plus b times x minus 3. Now I'm going to choose specific values of x that are going to find me a and b. And I'm going to choose smart values. I'm going to choose negative 2 first. Why? Because it's going to zero out this. Negative 2 minus 3 is negative 5. So we have negative 5b is equal to negative 2 times 4 is negative 8 minus 1 is negative 9. Divide both sides by negative 5, and we get 9 over 5. Negatives cancel out. There's our b. Now we're going to go back to this equation. And now instead of plugging in negative 2, I'm going to plug in positive 3. Okay, why? Because it's going to zero out this guy, and that's going to allow us to solve nicely for a. So 3 plus 2 is 5a is equal to 3 times 4 is 12 minus 1 is 11. Divide both sides by 5. And we get a is equal to 11 over 5, all right? So now we have values for b and a. Let's plug them in to this expression over here. So we got a is 11 over 5, and then we keep that denominator, x minus 3, plus b, which is 9 over 5 times x plus 2, like so. And that is your final answer. Boom, done. So for this one, we're going to start by factoring that denominator, right? Which is x minus 2 times x minus 3, because negative 2 and negative 3 multiply to 6 and add to negative 5. And then this equals a over the first one plus b over that second binomial. Cool. Next step, we're going to multiply both sides by this denominator, x minus 2, x minus 3. Okay. Multiply the left side, it's going to cancel out that denominator, which gives us 3x minus 1. On the right side, first we multiply it against this guy, and the x minus 2s are going to cancel out, which leaves us with a times x minus 3 plus, now this is going to multiply this guy, which means x minus 3 is going to cancel out, and we got b times x minus 2. Now we're going to choose nice values of x to solve for a and b. First, I'm going to choose 3. Why am I choosing 3? Because that's going to zero that out. And then I have b times 3 minus 2, which is 1. So b, 1b, is equal to 3 times 3 is 9 minus 1 is 8. There's my value for b. Boom. Okay, now we're going to come back to this equation. And instead of plugging in 3, I want this to zero out. So I'm going to plug in 2, right? 2 minus 2 is 0 times b is 0. 2 minus 3 is negative 1. So negative 1a is equal to 2 times 3 is 6 minus 1 is 5, which means a equals negative 5. Great. Now let's come back to this and let's rewrite it with a being negative 5 over that x minus 2, b being 8 over x minus 3. And that is how you do it. Done. So for this one, we actually now have a repeated factor in the bottom. So this kind of changes the way that we set it up. So it's already nice and factored here, essentially, right? It's x minus 2 squared. But when we have the repeated factors, you're going to have a over the factor by itself, right? And then the second one, b, is going to be this squared. So it's x minus 2 squared, like so. Okay, and after that little difference, it's essentially the same, right? We're going to multiply both sides by the denominator on the left-hand side, which is x minus 2 squared. So that's going to cancel this out here, so we have x. And then x minus 2 squared times a over x minus 2, one of these is going to cancel out, and we get a times x minus 2. And then when we multiply times b over x minus 2 squared, these cancel out completely, and we just have a b. Now we can solve for these individually by choosing a nice value for x. I'm going to start with 2. That's going to zero this out. And we're going to be left with b is equal to, plug in 2 there, 2, and that's it. Now we need to solve for a. And in this case, all I'm going to do is I'm going to plug in a different value for x. I'm going to plug in 3. It doesn't really matter because this one, we already know that b is 2. So watch this. If I plug in 3, I get 3 is equal to 3 minus 2, which is 1. So that's nice, right? 1a. And then plus b, which we already know is 2. Now we can subtract both sides by 2, right? And a is equal to 1, and we've done it. So now our partial fraction decomposition is 1 over x minus 2 plus b, which is 2 over x minus 2 squared. And that's how you do it. Done. So for this one, again, we have a repeated factor on the bottom. So the way we set this up is first the left side's the same, right? Negative 24x minus 27 over 4x plus 5 squared. And then on the right-hand side, we kind of start it like normal, right? For the previous questions, a over 4x plus 5. But then since it's 4x plus 5 times 4x plus 5, and it's kind of a duplicate, right? For the b value, we do b over that full denominator, 4x plus 5 squared. Okay, now we're going to follow that same step. We're going to multiply both sides by that denominator, which is 4x plus 5 squared. Now, of course, when we multiply this, it's going to just fully cancel out, and we got negative 24x minus 27. Now, when we multiply it against a over 4x plus 5, one of these is going to cancel out, and we're left with a times 4x plus 5. When I multiply it against this, the entire denominators are going to cancel, and we're simply left with b. Okay, now we're going to choose a nice value of x to zero this out, and I'm going to choose x equals negative 5 over 4, right? Negative 5 over 4 times 4 is negative 5. That's going to go to 0. So then we have b is equal to negative 5/4 times negative 24. That's like dividing by 4, which is 6. Negatives are going to cancel out. 6 times 5 is 30. So we have 30 minus 27. And therefore, b equals 3. Now we got b. Now we're going to go back to this original equation. I'm going to choose my next value to be -1. That's sort of arbitrary. It doesn't matter. I'm just doing it because it's going to make this go to 1. Because I already know what b is. B is 3. And if I plug in -1, I get -4 plus 5, which is 1, 1a. And then on the other side, -1 times -24 is 24, minus 27 is -3. Then we're going to subtract 3 from both sides, and we get a equals -6. All right, now I have my a and b values. Now let's come back to this, and let's plug and chug. So we got -6 over 4x plus 5, and then b is 3, plus 3 over 4x plus 5 squared. And this is the final answer. Done. So for this one, since we have a repeated factor down here, we're going to start as follows. 5 minus x over x minus 7 squared. And that's equal to, first it's a over this by itself, right? X minus 7 plus b over this repetition, right? Which is x minus 7 squared. Okay, now we got a good setup. Now we're going to multiply both sides by this denominator, x minus 7 squared. Of course, when we multiply the left side, it's going to cancel that out. And we got 5 minus x over here. When I multiply it against a, this is going to cancel out. I mean, this full term, right? That is going to cancel out. One of those is going to cancel out with x minus 7. So we have a times x minus 7. And then we multiply it against b over x minus 7 squared. Those will cancel out completely, and we get just b. Now, first I'm going to solve for b by choosing a nice x value. How about 7? That's going to zero this out, right? And then we get b is equal to 5 minus 7, which is -2. Cool, we got our b value. Now I'm going to choose another x value. This is a little arbitrary. I could choose pretty much anything, but I'm going to choose 8 just to make it simple. Because 8 minus 7 is 1, so that's 1a. I'm going to replace b with -2. I know it's -2. And then we got 5 minus, again, we chose 8 for x. 5 minus 8 is -3. Last step, we're going to add 2 to both sides, and we get a is equal to -1. Now we can rewrite this. We got -1 over x minus 7 plus b is -2. Again, I could say -2 or just plus -2 over x minus 7 squared. That's how you do it. Done. So for this one, we have some interesting things going on, right? We got 2x, we got x plus 1, but then we got that repeated factor on the bottom. So the way we're going to set this up is we got 5x squared plus 20x plus 8 over 2x times x plus 1 squared. Okay, then we need 3 fractions. Okay, first we have a over that first factor, linear factor, which is 2x plus b over x plus 1, but then we need a third. We need c over that full thing squared, x plus 1 squared. Now, like typical previous examples, we're going to multiply everything by that denominator on the left-hand side. So that's going to cancel that out, of course. So we get 5x squared plus 20x plus 8. Okay, now on this side, when I multiply it here, this is going to cancel out, and we get a times x plus 1 squared. And then when we multiply it against this, b over x plus 1, one of these cancels. So then we get b times 2x times x plus 1. And then when I do times this, right, these are going to cancel out completely, and we get 2xc. Now we need to solve for a, b, and c. Now the easy thing for my first x value to plug in is going to be -1. Now the reason why that's great is because it's going to zero out this and this, right? Because -1 plus 1, it's going to zero the whole thing out. Then we plug it in here. -1 squared is 1 times 5 is 5. Minus 20, right? 20 times -1 is -20 plus 8 is equal to, on this side, if we plug in -1, it's -2c. All right, now let's combine like terms. 5 minus 20 is -15, right? -15 plus 8 is -7. -7 equals -2c. Divide by -2, and we got our first value. C is equal to 7 over 2, right? Because the negatives cancel. Next, I'm going to plug in 0. The reason why is because it's going to zero out this and this, right? That's going to be pretty nice, right? So then I have a times 0 plus 1 squared, which is just 1. So then a equals, and on this side, 0, 0. It's going to zero those out. A equals 8. So check it out. Now I know that a is 8, c is 7/2. Last but not least, I'm going to plug in something easy for x. I'm going to plug in 1. And this is kind of arbitrary because now I have a and c. It's going to be pretty easy to solve for b. But now we're going to plug in everything, right? So 1 is going to go in. So we got 5 times 1 squared, which is 5, plus 20 times 1, which is 20. So that's 25 plus 8 is 33. And then is equal to, now we're going to plug and chug. So 1 plus 1 is 2, squared is 4. We already know A is 8. So 4 times 8 is 32. Plus, and then B is, of course, what we're still solving for. So 2 times 1 is 2 times 1 plus 1, which is 2. So 2 times 2 is 4B. And then plus 2 times 1, which is 2 times C, which is 7 halves. So 2 times 7 halves is 7. Look how nice this equation is. So now I have 33 equal to 4B plus 32 plus 7 is 39. Subtract 39 from both sides. 4B is equal to negative 6 divided by 4. That's going to be negative 6 over 4 or negative 3 over 2. All right, so this one took a little bit more room, but we still got enough. And now we're going to write the answer up top. So I have A is 8. So we got 8 over 2x, but I can simplify that, divide both by 2, and we got 4 over x. Then B is negative 3 halves, so I can just say minus 3 over 2, and then times that x plus 1 for B, right? And then last but not least, we got C, which was, what was it, 7 halves, so plus 7 over 2, and then with that existing denominator, x plus 1 squared. And here is your final answer. Boom, done. So for this one, before I start, I'm actually going to divide everything on top by 2 just to get that 2 out of there, just to make it a little bit easier. So then we got 27x cubed plus half of 127 is 63.5, x squared plus 40x plus 8. And then this is all over x squared times 3x plus 2. Okay, why not, right? So we got this. Now we're going to do our fraction decomposition. But the thing is, I have 2 things that are squared. So we're actually going to need 4 fractions. So let me show you how this breaks down. So of course, it's going to be this is equal to A over, we're going to need a lot of room for this, A over x plus B over x squared. So I'm addressing this right now. Plus C over this first or second part, 3x plus 2, and then plus D over 3x plus 2 squared. Now we're going to multiply everything by this denominator, right? We're going to multiply everything by x squared times 3x plus 2. Of course, that's going to cancel this out, so we just have this expression. So when I multiply this times a, right, you can see one of the x's are going to cancel out, and then so I get a times x times 3x plus 2 squared, plus, then I multiply against b, right, this term, and these are going to completely cancel out, and we get b times 3x plus 2 squared plus times this one, and one of these are going to cancel out, and we get c x squared times 3x plus 2. Last but not least, I multiply against this one, and these completely cancel, and I get dx squared. Now, the easiest thing to start off with in terms of plugging in is going to be 0 for x, right? Because if I plug in x equals 0, this, and this are all going to go away, right? So then I have, on the left side, 0, 0, 0. I have 8 is equal to b times, if I plug in 0, that's just 2 squared, which is 4. Divide by 4, and check it out. B equals 2. Great. So we now have our first value. Now we got to get everything else. The next thing that would be great to plug in would be negative 2/3, because that's going to zero out this, and this, right? Negative 2/3 times 3 is negative 2, plus 2 is 0. So negative 2/3. So negative 2/3 cubed is negative 8 over 27 times 27 is going to be, let me make some room up here, negative 8. Right, plus that squared is 4 over 9. That's going to be 4 times 63.5 is 254 divided by 9. And then plus 40 times negative 2/3 is negative 80/3, and then plus 8. And this is all equal to d times x squared, and x squared is again 4/9, so this is equal to 4/9 times d. Let's get some nice common denominators on the left-hand side. Negative 8 would be negative 72 over 9. This would be that as is. This would be negative 240 over 9, right? Multiply by 3. And then 8 times 9 is positive 72 over 9. All right, obviously these are going to cancel, right? And then negative 240 plus 254 is positive 14 over 9. Since the 9s are common denominators on the left and right hand side, we can cancel them out, divide both sides by 4, and D is equal to 14 over 4, which reduces to 7 over 2. Now what we're going to do is we're going to plug in our D and our B values, right? This is going to take a lot of work, so we're going to have to move it down and make more room. So we still got this whole thing on the left-hand side, and that's equal to this, but we're going to expand it, right? So it's A times 3x plus 2 squared times x gives us, if you expand it out, 9x cubed plus 12x squared plus 4x, right? But imagine what I did. I just did 3x plus 2 times 3x plus 2, and then I multiplied everything by x. And then plus b, which we already know what b is. B is 2, so then it's going to be 2 times this squared, which is 9x squared plus 12x plus 4. Again, just foiling that out. Plus c with this whole thing distributed, right? C times 3x cubed plus 2x squared. And then plus d times x squared. D we already know is 7 halves times x squared. Now we're going to continue to multiply out and kind of like simplify the right-hand side. So I have a 9x cubed plus a 12x squared plus a 4x plus, and then we multiply this out, 18x squared plus 24x plus 8. And then I've got plus c3x cubed plus c2x squared plus 7 halves over x, or times x squared. Now what you'll notice that's interesting is I only have 2 terms with x cubed, right? I have 9a and c3. And then I have only 1 term with x cubed here. That's pretty interesting because that means that when I add these together, 9a plus 3c has to equal 27. Okay, that's cool. We're not totally there yet, but that's interesting. The other interesting element is we've got x and x, right? We only got 2 with just x. That means 4a plus 24, okay, 4a plus 24 must be equal to whatever is times x there, which is 40. Check it out. We got a nice little system of equations. We can first solve for a, plug and chug, solve for c. Okay. So we're going to minus both sides by 24. That's 16 equals 4a. Divide by 4, and a equals 4. Beautiful. Last but not least, plug it in here. 4 times 9 is 36 plus 3c. Minus 36 from both sides, negative 9 equals 3c. Divide by 3, c equals negative 3. Okay. So now I just rewrote C, B, D, and A, and the original sort of decomposition. Now we can finalize this. So since we got A is 4, we got 4 over x plus B, which is 2 over x squared, plus C, which is negative 3 over 3x plus 2, or we could just say minus here. Both are correct. And then last but not least, plus D, which is 7 over 2, and then times 3x plus 2 squared. Man, oh man, that is how you do it. Done. All right, so for this one, as we do the decomposition, first I'm going to rewrite that numerator, right? 6x plus 11 over that denominator, x plus 2 times x squared plus x plus 3. Great. Okay, so what we got here is we got a linear factor and a quadratic, and it's saying that, you know, that's what it is, a non-repeating quadratic, right? And the way we break this up is as follows. For this linear factor, we do our typical thing, right? A over x plus 2. And then for this quadratic, it's basically similar, but a little bit different. And I'm going to show you what you do. Instead of just like a typical b or something, it's bx plus c. Now, this is basically so think about this, right? This is a quadratic. This is 1 degree less, which is a linear. So that's the idea. When you have this quadratic that you can't factor or turn into linear components, you have to have this format. Okay, now after this, we follow that same process. We multiply everything by the denominator over here, which is x plus 2 times x squared plus x plus 3. Obviously, that's going to cancel this out. So we have that numerator. And then we multiply against this term, right? X plus 2 is going to cancel out, and we get a times that quadratic. And then we multiply against this term, right? These are going to cancel, and then you get bx plus c, that numerator, times what we got left over, which is x plus 2. Now we're in a good spot because I can choose a nice value for x to eliminate this and just solve for a, which is going to be negative 2. So first we're going to try negative 2 for x. Over here we get negative 2 squared, which is 4 times 4 is 16. minus 12, right? Negative 2 times 6 is negative 12, and then plus 11. So that's the left side is equal to, this is gone. And then over here we have negative 2 squared, which is 4 plus negative 2 plus 3, right? That's going to be 2 plus 3 is 5. And on the left side, we get 16 minus 12 is 4 plus 11 is 15. So we get 15 equals 5a. Divide by 5, and we get a is equal to 3. Now that we got a value for a, what I'm going to do is I'm going to plug a back into this equation and just kind of multiply out and simplify the right-hand side. So we got 3 distributing, and then we got 3x squared plus 3x plus 9, right? A is 3, so boop, 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 like that. And then we're going to FOIL these guys. So that's going to be plus bx squared. So I have to go to another line, just ran out of room. Plus 2bx. And then plus cx, and then plus 2c. Okay, so this is pretty helpful because I can already see that the constants should be 11 over here, right? And that means the constants here, 9 and 2c, should add up to 11, which means c has to be 1. You see, so now we know that c is 1. And then if I know that c is 1, all I have to do is solve for b. Now here's the dealio. I only see 2 terms with x squared, so I can do it from here, right? Because it's 3x squared plus bx squared should equal 4x squared. So what does that mean? B has to be 1. So now that we got a, b, and c, we can come back to this expression and plug and chug. So our final answer is a, which is 3. That goes over x plus 2. And then we got plus b, which is 1. So that's 1x plus c, which is 1 over that denominator, x squared plus x plus 3. And that is how you do it. Done. All right, so for this one, what we're going to do is, once again, we're going to set this equal to a over that linear factor, x minus 1, and then plus bx plus c over that quadratic factor. All right, excellent. And now the next step is, of course, to multiply everything by this giant denominator. Now, when we multiply this by that, it just cancels out that denominator. So we're left with that numerator. And that's equal to, we multiply this by this, and you'll notice that x minus 1s cancel out. So we have a times that quadratic. And then when we multiply this by this, right, the quadratics cancel out, and we get bx plus c times x minus 1. There we go, x minus 1. Okay, so I had to kind of go down on this line, but it's still adding together. All right, now we're going to choose some nice values of x to quickly solve for a. Well, if I choose 1, it's going to zero this out. That's great. So we got x is equal to 1, and goodbye. And then that means if I plug in 1 here on the left-hand side, I get negative 2 times 1 squared, which is negative 2, plus 10 times 1, which is 10, plus 4, is equal to a times 1 plus 3 plus 8, which is 12a. Now we add these together. That's going to be 8 plus 4 is 12. 12 equals 12a, which means a equals 1. Great. Now we're going to reset this equation, and I'm going to replace a with 1, meaning I can pretty much just get rid of a, right? 1 times all that is still that. So we're now going to simplify this a little bit, and this is going to be pretty straightforward once we do that. So there's really not much to simplify here, but here I can FOIL this out. So again, the left side stays as is. Over here we got x squared plus 3x plus 8, and then here we have plus bx squared minus bx plus cx, and then minus c. Okay, we again ran out of room, but that fits. Okay. Now, the first thing I want to look at are these nice constants, right? We have 8 and negative c should match up with this constant, right? So if that's the case, 8 minus what gives me 4? It's 4, right? So c, therefore, has to be 4. Let's box both of these. Now let's figure out what b is, and we can do that from the x squareds, right? I mean, you could do it multiple ways, but the x squareds are perfect, right? We have 1x squared and a bx squared. And those two combined should give us a negative 2x squared. What does that mean? That means b must be negative 3. Negative 3 plus 1 is negative 2. So b is negative 3. Okay, now we can give our final answer going back to this blueprint up here. So we got a, which is 1 over that x minus 1, plus b, which is negative 3x, and then c is 4, so plus 4 over that whole denominator, x squared plus 3x plus 8. And there is your answer. Done. So for this one, we're going to start by writing this out again. And with the partial fraction decomposition, we've got a over that linear component, x plus 3. And then for the quadratic, right, we have to have bx plus c. That's the format, right? When we have a non-reducible quadratic like that over the quadratic. Okay, now we're going to start with our typical step. We're going to multiply everything by that denominator on the left-hand side. X plus 3 times x squared plus 6x plus 1. Cool. So that's going to cancel that out there, which means we just have the numerator left alone because we're multiplying everything by this, right? And then we multiply that against this. These guys are going to cancel out, and we have a times x squared plus 6x plus 1. And then we multiply against this guy, right? These are going to cancel out, and then we have plus bx plus c times x plus 3. All right, amazing. Now we need to choose a value of x that's going to help us solve for a first, and I think -3 will be perfect, right? -3, it's going to zero this out completely, right? Because -3 plus 3 is 0. And then we're going to plug it in over here. -3 squared is 9 times 4 is 36. -3 times 17 is minus 51, and then minus 1 is equal to a times -3 squared is 9, right? Plus -3 times 6 is -18 plus 1. Okay, and as we simplify, 36 minus 51 is -15 minus 1 is -16 is equal to a, which times, let's see, 9 minus 8 is -9 plus 1 is -8. That's beautiful. We divide by -8 and we get a nice whole number of 2. Great. So there's our a value. Now let's get b and c. So again, I'm going to plug in that 2 and we're going to kind of simplify this. So this left side is going to stay the same. Let's see, I'm trying to write it small here. 4x squared plus 17x minus 1 is equal to 2. I'm going to plug it in. Let's distribute 2x squared plus 12x plus 2. And then for here, we're going to FOIL, okay? bx, bx squared, 3bx, cx, and 3c. So let's write that out. bx squared plus 3bx plus cx plus 3c. Okay, now we're going to do a little matching, right? And I see that I have 4x squared for the coefficient of the x squared over there. Here, I only have 2 terms with x squared. I have 2x squared and bx squared. Those two added together should be 4x squared, which means b is also positive 2, right? 2 plus 2 is 4. Last but not least, we need to figure out what c is. C is going to be pretty nice because there's a constant, 3c, and there's the other constant, 2, right? So 2 plus 3c is supposed to give me -1, which means that this has to equal -3. -3 plus 2 is -1, meaning that c is -1. Now going back to this, we can get our final answer. We got a, which is 2 over x plus 3, right, over that. And then plus b, which is 2x, plus c, which is -1 over that quadratic, x squared plus 6x plus 1. And that is how you do it. Done. So for this one, before we start, we're actually going to want to factor that difference of cubes. And if you remember, here, let me write out the numerator. If you remember how to factor it, we have this thing called same, and then we got different, and then plus, meaning same sign here as there, then the different sign, which is plus, and then it's always plus at the end. And then this is how you factor it, right? It's the cube root of that, and the cube root of that. So cube root of x cubed is x, cube root of 1 is 1. And then over here, we have this first term squared. Then in the middle, we have x times 1. These two multiplied against each other, which is x. And then over here, we have this term squared, which is 1. Okay, now we have that nice format that we're used to, and now we can do our fraction decomposition. So we got a over that first linear term, x minus 1, plus bx plus c over the quadratic. Now we're going to multiply both sides by this entire denominator here. When we multiply against this, everything's going to cancel out. So we just have the numerator. And then when we multiply against this term, these are going to cancel out. So then we have a times x squared plus x plus 1. And then when we multiply against this, right, these are going to cancel. So then you just have bx plus c times that remaining x minus 1. All right, now we want to choose a nice value for x to solve for a. I'm going to choose 1, right? Because that's going to zero this out right here, and that's going to multiply everything by 0, and that's going to go away. So then let's plug and chug. So plug in 1. 4 times 1 squared is 4, plus 5 times 1, which is 5, plus 3 is equal to 1 squared, which is 1, plus 1 plus 1, which is 3a. So 3a equals 8 plus 4 is 12, divided by 3, and we get a equal to 4. Great, so we got our first value. Now we want to figure out what b and c are, so let's go back to this and let's remove that x. Now since I know that a is 4, I can plug it in here, and then let's rewrite this equation. So we got 4x squared plus 5x plus 3 is equal to 4, so I'm going to distribute that 4x squared plus 4x plus 4, and then now we're going to FOIL this out. Plus bx squared minus bx plus cx, and then minus c. Okay, great. Now first let's solve for b. The nice thing about b is I see a 4x squared and a bx squared being added together to give me a 4x squared. Well, wait a minute. What does that mean? That means that b has to be 0, right? Because we already got a 4x squared. So b is 0. Last but not least, we need c. Since the constant is 3, and the only constant numbers here are 4 and negative c, 4 plus negative c has to equal 3, meaning c is 1, right? 4 plus negative 1 is 3, so c is 1. Great. Now we can rewrite this by plugging and chugging. A is 4, so we got 4 over x minus 1, plus b, which is 0, so 0 times x is 0, plus c, which is 1, and then over that quadratic, x squared plus x plus 1. And there is your final answer. Done. All right, so for this one, before we begin, we have to factor that denominator. And that denominator is a sum of cubes. The way you factor it is you go like this. Something called same, meaning same sign in the first one. Different, next one is different, meaning minus, and then plus, okay? And then what goes here, here, and all these spots, right? Here goes the cube root of x cubed, which is x, the cube root of 27, which is 3. And then here it's that first term squared, the product of the two, 3 and x, and then the last term squared. Now we got the linear factor and the quadratic, so we write it out as a over x plus 3 plus bx plus c. It's a linear factor over that quadratic, x squared minus 3x plus 9. Great. Okay. Now we're going to multiply everything by that denominator on the left-hand side, which is x plus 3 times x squared minus 3x plus 9. So we multiply. That's going to cancel this out on the left-hand side. So we got the numerator. And then on the right-hand side, when we multiply against this, the a plus 3s are going to cancel out. And we got a times the quadratic. And then over here, we got this entire thing canceling out when we multiply against that term. So we got bx plus c times this remaining linear factor, which is x plus 3. Great. Okay, now we're going to choose values of x to solve easily for a. How about negative 3? That's going to cancel this out, right? So we got x equal to negative 3. Let's plug and chug. Negative 3 squared is 9 times 3 is 27. Negative 3 times negative 7 is positive 21 plus 33 equals negative 3 squared is 9. And then negative 3 times negative 3 is 9. So 9 plus 9 plus 9 is 27. So we got 27a. Now we're going to add these up over here. 27 plus 21 is 48. 78 plus 3 is 81. Equal to 27a. Divide both sides by 27. A is equal to 3. Cool. We got that. Now we're going to plug and chug in here, and we're going to distribute, right? So we got 3x squared minus 7x plus 33 on the left-hand side. Over here, 3 distribute. We got 3x squared minus 9x plus 3 times 9 is 27. And then we're going to rewrite this FOILed out. And so it's got b x squared plus 3bx plus cx plus 3c. Okay, now we can start to figure out what b is. Notice I have bx squared and 3x squared adding to 3x squared. Well, what does that mean? It means b must be 0, okay? So b has to equal 0. And then what about c? I see that 27 plus 3c, those are the only constants, equals 33. That's the only constant on the left side, which means 27 plus 6 is 33, meaning 3 times what is 6? It's 2. So that means c is equal to 2. Last but not least, now we're going to rewrite it with these as our fractions. So we got a, which is 3, over x plus 3, plus 0 for b, so that just goes to 0, plus c, which is 2, over that quadratic, x squared minus 3x plus 9. And that is how you do it. Done. All right, for this one, before we begin, we're going to have to factor that denominator, right? Because it's a difference of cubes. The way you factor a difference of cubes, once again, is it's going to be a linear factor, binomial, and then a trinomial. So you take the cube root of this, the cube root of that, and that is 2x, and that is 3. And then we do something called same, different, plus. Same sign here, different sign here, and then the last one is always plus. And then over here is this first value squared, which is 4x squared. In the middle, it's the product of 2x and 3, which is 6x. And at the end, it's this squared, which is 9. Great. Now we can do our partial fraction decomposition. So we got a over that linear factor, 2x minus 3, plus bx plus c over the quadratic. As per usual, we're going to multiply by this denominator here on both sides. So we got 2x minus 3 times 4x squared plus 6x plus 9. And then, of course, when we multiply on this side, it just cancels that out, and we're left with that nice numerator. And then over here, when we multiply against this term, this cancels out with this, and then we have a times that resulting quadratic. And then we multiply against this, right? That cancels out with that, and then we're left with bx plus c times that linear remaining factor, the 2x minus 3. Okay, great. Now we're going to choose a nice value for x that's going to eliminate this whole thing, meaning zero this out. And that's going to be x is equal to 3 over 2, okay? So we plug that in again, that goes to 0. And then now we got a lot of numbers that we have to crunch here, which is kind of annoying, but we're going to have to do it. So 3 halves squared is 9/4 times 4 is 9. And then 3 halves times 4, what is that, 2, 6. And then plus 3 halves, or sorry, then just 12. Actually, that wasn't that bad. Equal to a, again, 4x squared, just like here, is 9 plus 3 halves times 6, that's 3, 9, and then plus 9. Okay, we scrunched it in there, made it work. 9 plus 6 is 15, plus 12 is 27. 9 plus 9 plus 9 is also 27. Lo and behold, a is equal to 1. Beautiful. So we got a is 1. Now we're going to try and get b and c. And what we're going to do is we're going to go ahead and rewrite everything. So first we got 4x squared plus 4x plus 12 is equal to, since a is 1, a times all of this is just 4x squared plus 6x plus 9. And then plus this FOILed out, which is b2x squared, those two multiplied, and then minus 3bx plus 2cx, and then minus 3c. Okay. So we can figure out what b is pretty quickly because I got the 4x squared and the 4x squared matched up, and then this is the only other x squared. Well, if these two are supposed to be matched up, b has to be 0 because this can't happen, right, for these two sides to be equal. So b has to equal 0. And then for c, we can just use these nice constants, right? 9 minus 3c is equal to this constant, which is 12. Well, if c is -1, -3 times -1 is 3, plus 9 is 12. That means c is -1. So those are my values. Now let's go back to this and plug and chug. So we know a is 1. So we got 1 over 2x minus 3 plus b, which is 0. 0 times x is 0. Plus c, which is -1. Or I could say minus, but we'll just say plus -1 over that quadratic 4x squared plus 6x plus 9. And that is how you do it. Boom. Done. All right, this one looks pretty crazy, and it is what it is. So first thing we're going to do on that denominator is I'm going to factor x out, okay? And then we got x cubed plus 216. All right. So then we have to, oops, that parentheses came out weird. So then we have to factor this sum of cubes. So we got x, and then again, it factors to, we got that same different plus situation. So we take the cube root of that and that, so that's x, and that's 6. Over here we got the x squared. Here we got the product of x and 6, which is 6x. And then at the end we have 6 squared, which is 36. So that's the kind of factored out denominator, and then the numerator we'll leave as is. All right, so now we have our linear factors. So we have a over x plus b over x plus 6. That's the next linear factor. And then we have plus cx plus d, it has to be a linear factor on top over that quadratic. All right, so you can see this is going to be a lot of work, but we got it set up. Now we're going to follow this typical protocol. We're going to multiply everything by this denominator right here. So let's write that out. So when we multiply the left side, this cancels out and we get that numerator. And this is equal to this times this, which makes the x cancel out. So we have a times x plus 6 times x squared minus 6x plus 36. Then when I multiply this against this, these are going to cancel out. So then we're left with, let's see, bx times x squared minus 6x plus 36. And then last but not least, we got plus this times this, and that's going to cancel out this entire thing. And then we're going to have x times x plus 6 left over, and then times cx plus d, like so. Okay, now we got to choose some nice values for x to plug and chug to start solving. I like, since I have an x here and an x here, if I plug in x equals 0, that's going to be amazing. So let's write that out. So over here, 0, 0, 0, we get 216 is equal to 0, 0. Those two cancel out. And then we get a times 0 plus 6 is 6. And then 0, 0, 36, like so. 6 times 36 happens to be 216. So we got 216a. Therefore, a equals 1. Great. So we got our first answer. Next, what I want to do is I want to plug in -6, right? Because that's going to zero out this and this. And when you plug it all in on the left side, if you evaluate it, it equals -648. Okay, what about on the right-hand side? So we got -6 squared, which is 36, minus 6 times -6, which is 36, positive, and 36. 36 plus 36 plus 36 is 108. And then it's times right? We're plugging in -6 for x, -6b times this, right? So -6 times 108 happens to also be -648. So we got -648b equals -648, which means divide both sides by that, and we get b is equal to 1. Okay, so now we got A and we got B. We got to get C and D. So what I'm going to do now is I'm going to plug in 1 and 1. So now what I'm going to do is I'm going to kind of take this whole portion up here and I'm going to plug in 1 and 1 for A and B and simplify this out. So we're going to need a little more room down here. And of course, this left side is going to stay as is. So A is 1, it's just going to be this. And when we FOIL this back out, if you remember it, that would be x cubed plus 216, okay? And then for this one, again, b is 1, so if I distribute just the x, right, we get plus x cubed minus 6x squared plus 36x. And then we have this last little piece, which is, first I can distribute in that x, so that's going to be x squared plus 6x. And then we got to multiply it by cx plus d, so we're going to FOIL that out. So we get plus cx cubed plus dx squared. This is a long one, plus 6cx squared, and then last but not least, plus 6xd, okay? So we got all of this. Now we're going to see if we can figure this stuff out. Now, what I see right off the bat with the x cubeds is that I have x cubed, and cx cubed. And they're supposed to all three add together to get -2x cubed. So 1 plus 1 is 2, plus c is supposed to be -2. That means c has to be -4. Okay, we got that. And now we can solve for d. Notice I have 6xd and 36x. And these two are supposed to add together and equal that 36x. Well, I already have 36x, so the d has to be 0. So now I come back up top to the original partial fractions, those three. And now we're just going to plug and chug a, b, and c. d is 0, so we can get rid of that. So let's see what we got. We got 1 over x plus b, which is 1. Over x plus 6, and then plus -4x plus 0, so we don't have to write it, over that quadratic, x squared minus 6x plus 36. And there you go. That's how you do it. Done. All right, so for this one, we're going to first rewrite it down here. And now it's like we have a quadratic that's being squared again. So the way we write this out is kind of similar. We have a linear factor first, right, ax plus b, over the original quadratic without the extra exponent. And then we have another series where it's cx plus d, and now it's over this, but the whole thing squared. All right, now we're going to start the same way, multiply by this denominator here against both sides. So of course that's going to clear out this denominator for this term. And then when we multiply this, 1 is going to go away with that. So we now have ax plus b times x squared plus 1 in parentheses. And then we multiply this against this. The entire denominators cancel, and you're just left with, I'll put it down here, cx plus d. All right, next we're going to FOIL everything out and simplify both sides. So over here we got ax cubed, and then we got ax, then we got bx squared, and then we've got b like that, and then we still got the cx and the d. Okay, now when we look at these two equations on the left and right, we can start to match some things up. First of all, there's 1x cubed with a coefficient of 1. There's only 1x cubed here. That means a has to equal 1 for these two sides to match up. Okay, next we see that we've got an ax and a cx only with a singular x. Here we have a 5, right? That means since I know that a is 1, c has to be 4 because 4 plus 1 is 5, right? So we know that c is 4. Last but not least, we have to figure out b and d. Okay, now for b and d, we know that b and d as the constants, they both add up to 9. So I know that b plus d is 9. And I also know that bx squared is the only x squared, and that must match up with 6x squared. That means b has to equal 6. And if b equals 6 according to this equation, d is equal to 3. Now we come back to the top with these 4 values and these original fractions, and now we're going to plug and chug. So we got 1x plus 6, that's a plus ax plus b, over x squared plus 1, and then plus 4x plus 3, that's c and d, right? 4x plus 3 over this x squared plus 1 to the second power. And that's how you do it. Done. All right, for this one first, we're going to rewrite it down here. And what we're going to do is first we got a over the original linear factor. Then we have ax plus b over what's inside the parentheses. And then we got another linear factor, cx plus d over that squared. All right, now we're going to multiply both sides by that denominator, x plus 2 squared. That's, of course, when we multiply it here, these guys are going to cancel out. So we just have that nice numerator like so. Then we multiply against this, right? One of these is going to cancel out with this. So then we got ax plus b times x plus 2. And then when we multiply against this guy, the entire denominators are going to cancel out. So we're just left with cx plus d. All right, great. Now we're going to FOIL this out, and then we're going to start to simplify. So we got ax squared plus 2ax plus bx plus 2b, and then we still got cx plus d. Great. Now the cool thing is I already have only 1x squared over here, 1x squared over here. That means they have to match up. That means since that's 1x squared, a has to be 1. Great. All right, so now we can make some more equations. First thing I'm going to do is I'm going to plug in -2 for x. That's going to zero out this whole thing. And then we have -2 squared is 4 plus -10, which is -6, plus 5 is -1, is equal to, and then we plug it in here because, again, this zeroes out. We got -2c plus d. That's one equation. And then another one we can match up with the x terms, right? We've got 2, and a is 1. So we got 2 plus b plus c is equal to that term, right? So 2 plus b plus c is equal to 5. 2 plus b plus c is equal to 5. Another way of saying that is b plus c is equal to 3. And one more, we have the constants, 2b plus d also has to equal 5. So when it comes to the relationship of b, c, and d, what you're going to see is we actually have multiple possibilities, okay? Because we don't have enough information to limit it down to one more choice. But watch this. This is pretty cool. So, you know, if we look at these two equations and this one, you know, one option is I could say that, you know, b is 1 and c is 2, right? 1 plus 2 is 3. It satisfies that. And if b is 1, right, you plug it in here, 2 times b is 2 plus what is 5, it would be 3. This is one viable option. I'm going to show you another one now. Another option could be b is 2, c is 1, okay? And then we come back to this equation. 2 times 2 is 4 plus what is 5? 1. Okay, that's another option. Again, in this case, it works here too. -2 times c, which is 1. -2 plus 1 is -1. Okay, now I'm going to show you that both of these options work. So, you know, with a equaling 1 and b 1, c 2, d 3, we could say 1x plus 1 over x plus 2, right? Plugging in plus, and then c, we said for the top one is 2. 2x plus d, which is 3, over x plus 2 squared, right? This is one option, but I could have also used 2, 1, and 1. So this could have been a 2, this could have been a 1, and a 1. I'm just saying that's the second option. We're going to leave this one up here because this is what they got in the back of the book. But let me show you in Desmos that both of these would work. So here's the original function, right? And this is what we first presented, and this is what's in the back of the book. You see the functions are the exact same. They overlap. But the same thing is true with our other variation, right? When I change to B, C, and D, because that also matches up exactly. So anyways, that's how you do it. Done. So for this one first, we're going to rewrite it down here. And then again, it's a quadratic squared. So what we're going to do is first the first linear factor, ax plus b, over this denominator without that exponent. And then our second linear factor on top, right, cx plus d over this entire denominator. Now we're going to multiply everything by the denominator, x squared plus 3x plus 25 squared. So over here, of course, that's going to cancel out completely. And we got x squared plus 25, and then over here when we multiply against this term, these are going to cancel out, but you're still left with that quadratic. So ax plus b times that entire quadratic, x squared plus 3x plus 25, and then when we multiply against this, the entire denominator will cancel, and we're just left with cx plus d. Okay, great. Now we can start to figure stuff out. Now, one thing that's interesting that you'll notice is we only got an x squared here. So when I start to FOIL this out, I'm immediately going to get ax cubed. Now we can stop there because there is no cubic over on the left-hand side, which means for this to work out, a has to be 0, right? Because we can't have an x cubed in the mix. So a is 0. That's pretty helpful because now I can simplify the entire right-hand side, right? X squared plus 25 on the left is equal to, that's basically 0. So then we just distribute the b. We got bx squared plus 3bx plus 25b, and then we have plus cx plus d. Now, since I know the only x squared terms are here and here, they have to match, which means b must be 1, okay? So then if b must be 1, this is just 25. And 25 plus d, the only other constant, has to be 25. Well, that means d has to be 0. And last but not least, we've got c, right? So we've got a 3bx and a cx adding together to make what? Well, there is no x term on this side. That means 3 times b with 3 times 1, right? 3 plus c has to be 0. That means c would have to be the opposite of 3, which is -3. Okay. Now we can write out our final answer, a being 0, plug and chug. So 0x plus b, which is 1. So that's 1 over x squared plus 3x plus 25. And then plus c, which is -3 times x plus d, which is 0, over that denominator, x squared plus 3x plus 25, and this whole thing squared. And that's how you do it. Done. All right, so for this one, I'm going to rewrite this over here. And notice what we have, right? We have a linear factor and then this quadratic, and it's being squared. So we got to have 3 different pieces. First, we're going to have a over x, then we're going to have bx plus c, for this inside quadratic, x squared plus 4. And then last but not least, we need dx plus e over this entire piece squared. Great, now we're gonna multiply everything by that nice denominator. So when we multiply against this term, of course, the denominators will cancel, and we'll just get 5x plus 2. And then over here, when I multiply against this term, the x's are gonna cancel. And then we have a times x squared plus 4 squared. Then when we multiply against this term, right, this and one of these will cancel. So then we have bx plus c times x, and then times x squared plus 4. And last but not least, when we multiply against here, this entire thing will cancel out, right? So then we just have x times dx plus which makes dx squared plus ex. Okay, great. Okay, now let's FOIL everything out and simplify a little bit, and we're going to make a little bit more room. This is a long problem, so we have, of course, still 5x plus 2 on the left-hand side. And then as we simplify this, right, if I square x squared plus 4, I get x to the 4th plus 8x squared plus 16. I'm just putting a little space there because we have to distribute the a. So we got a, and a. And then over here, if I distribute the x like so, I'll have x cubed plus 4x. And then we're foiling that against bx plus c. So we got to write these out. Then I have bx to the 4th plus 4bx squared plus cx cubed plus 4xc. And then we've got the dx squared and ex. Okay, great. Now we can start to kind of look at everything. Now, here's the deal, right? We only have one constant. I see one constant here, a times 16. Everything else is kind of matched up with a variable. And I only have one constant here, which is 2. So that tells me that a definitively must be whatever times 16 equals 2, which is 1/8. So a is 1/8. Now we get another interesting situation, right? Ax to the fourth plus bx to the fourth has to equal what? Well, there is no x to the fourth. That means they have to cancel out. That means a and b have to be opposites, which means b has to be negative 1/8. I also only have 1x cubed, and that's multiplied by c. No x cubed over here, so c must be 0. Okay, we're making good progress. Now, let's get to d and e. So again, since c is 0, this would go away, and that means my only x term, singular x, is going to be ex. And since it's 5x over here, e has to equal 5. Okay, now we got to figure out d. So I have an x squared here, here, and here. And since there's no x squared on the left side, those have to add up to cancel out essentially, right? So since I know that a is 1/8, 1/8 times 8 is just 1. So we have x squared plus, and then we have negative 1/8 times 4, which is negative 1/2 x squared, and then plus dx squared, and all of these have to zero out. So x squared minus half x squared is positive 1/2 x squared, therefore d must be negative 1/2. So d is negative 1/2. Okay, now we have a, b, c, d, and e written up here. Let's plug and chug. So a is 1/8, right? So we got 1 over 8x like this, right? 1 over 8x plus b is negative 1/8, c is 0. So this goes away. So if we have negative 1/8, we could say negative 1 and then 8 on the bottom, and that's going to multiply that entire x squared plus 4. And then last but not least, we have d, which is negative 1/2, e is 5. So we can say negative 1/2, so 2 down here, and then it's times x squared plus 4 squared. And then we will move this over. And that's negative 1 is going to be with the x. And then we have the 5. But here's the interesting thing, right? The e is supposed to be 5, but now I've thrown the 2 on the bottom for everything. So at the end of the day, to throw that 2 on the bottom from the 1/2 for everything, I also have to multiply that e by 2, which makes it 10. All right, there it is. There's your final answer. Done. So for this one, the way we're going to start is first by recognizing that this is actually factorable. And the way you can rewrite that is x times x minus 1, right? Factor out an x. And then it's still this whole thing squared. Now, if I distribute that square, check it out. I got 2x minus 9 over x squared times x minus 1 squared, right? Distribute that radical, boom and boom. I mean, not radical, sorry, exponent. Okay, now we can do our partial fraction decomposition. And here's how we're going to do it, right? We have a over just this, right? Just the x, and then plus b over x squared plus c over the second one, x minus 1, just without the square, and then d over x minus 1 squared, like so. Okay, now we're going to multiply everything by that denominator, x squared times x minus 1 squared. We multiply against this. One of the x's cancel out, and we get a times x minus 1 squared. By the way, over here, when we multiply against this, these whole denominators cancel out, and we get 2x minus 9. Now, when I multiply against this term, the x squareds cancel out, and I get b times x minus 1 squared. Then when I multiply against this term, one of these cancels out with that, and then I have plus c times x minus 1 times x squared. And last but not least, when I multiply against this term, s and this cancel out, so I just have plus dx squared. Okay, great. Now to solve for d very quickly, I got a nice opportunity here to plug in 1 for x. So when I plug in 1 for x, that zeroes out, that zeroes out, that zeroes out, and we get dx squared is equal to 2x minus 9. Again, 1, we plug it in, so we get d times 1 squared, which is d, equals 2 times 1, which is 2, minus 9 is negative 7. So there's our first thing, d equals negative 7. Another number that I can plug in easily would be 0 for x, right? That's going to zero out this, and this, right? They all have an x like that. And then this one we plug and chug. 0 minus 1 is negative 1. Negative 1 squared is 1. So we have 1b is equal to 2 times 0, which is 0, minus 9 is negative 9. Check it out. We got two values now, b and d. We just need a and c. Now just making a little bit more room. Now I'm going to simplify the top, knowing that negative 7 is d and negative 9 is b. So we're going to FOIL everything out. We got 2x minus 9 is equal to, at first I got x minus 1 squared, which is x squared minus 2x plus 1, right, when I FOIL that out. So then multiply by ax, I have ax cubed minus, again, ax times negative 2x, which is 2ax squared, and then ax times 1, which is plus ax. And then we got plus b times, again, this, because that's x minus 1 squared. So b times x minus 1 squared, or this is bx squared minus 2bx plus b. And then over here, we've got c times x minus 1 times x squared. So we distribute that x squared in. It's x cubed minus x squared. So it's cx cubed minus cx squared, and then last but not least, plus dx squared. So if I look at the x cubes, okay, I got ax cubed and cx cubed. Those are the only two. But when they add together, they should cancel out because there is no x cubed on the other side. So that means that they're opposites, right? A, therefore, equals negative c, or vice versa. I also see that I've got ax and negative 2bx. Those are only single x values. So ax minus, and then 2bx, we already know b is negative 9, so negative 2 times negative 9 is positive 18x. We already know that this has to equal 2x, right? So a, therefore, what plus 18 is 2? That's negative 16. So a is negative 16, and then c, since it's the opposite, is positive 16. Okay, so now that we boxed a, b, c, and d, let's move it up top so we can now finalize our answer. So we got negative 16 over x minus 9 over x squared, right? Because b is negative 9. And then we got c, which is 16 over x minus 1. Last but not least, we got d, which is negative 7 over x minus 1 squared. And that's how you do it. Done. So for this one, what we have is this thing to the third power. So let's rewrite this down here. So since it's a linear cube, the way we're going to do it is first we got a over just that x plus 1. Then we got b over x plus 1 squared. And then we got c over x plus 1 cubed. Okay, great. Now let's multiply both sides by this denominator. So we're going to multiply both sides by x plus 1 cubed. And over here, when we multiply it, that's just going to kill the denominator. We got x squared plus 4. When I multiply against this term, one of them is going to cancel out. So that's going to be squared, right? So then we have a times x plus 1 squared. And then when we multiply against this guy, right, two of these are going to cancel out with this whole thing. So we've got b times just x plus 1. And then last but not least, when we multiply against this one, the entire denominator is going to go, and we're just left with c. Now we can quickly choose nice values of x to solve for c. What about negative 1? When I do that, that zeroes out. That zeroes out. So that's beautiful. So now we have c is equal to negative 1 squared, which is 1 plus 4. Therefore, c is 5. Next, I can quickly tell that when I FOIL this, right, I'm going to get x squared plus 2x plus 1. But that's going to be my only x squared in this entire right-hand side. And since it's going to be multiplied by a, we're going to have ax squared. That's the only x squared, which means it has to match up with this, meaning that a would have to equal 1. Okay. Last but not least, we have to get b. And to do that, we're going to plug in 1 and 5, and then we're going to solve for b. So we got x squared plus 4 is equal to, again, 1 is just kind of there, so it just doesn't really do anything. So that just becomes x squared plus 2x plus 1 when we FOIL it. Then we got plus bx plus b, and then we got plus c, which is 5. Okay, so it's on the right-hand side. And since the only constants here are 1, b, and 5, we can kind of figure that out because 1 plus b plus 5 has to equal 4. So 4 equals 6 plus b. So what does that mean? That means b must equal negative 2. Great. Okay, now we can write out our final answer here. plugging and chugging, right? So we got a, which is 1, so we got 1 over x plus 1, and then b is negative 2, so we got minus 2 over x plus 1 squared, and then we got plus c, which is 5 over x plus 1 cubed, okay? And that's how you do it. There's your answer. Done. So for this one, as we start, notice there's nothing really to be done with these two, right? These two are kind of good to go, so we don't have to worry about them. But what we do maybe want to decompose a bit is this, right? So what I'm going to do first is I'm going to distribute that negative just to make it a little easier because it is minus, right? So distribute that up top, so then that becomes positive 1 minus x, basically flipping this around. And then we're going to factor that denominator, which gives us, what two numbers multiply to negative 16 add to negative 6? That's negative 8 and positive 2, right? Okay. And we're going to do our fraction decomposition. So we got a over x minus 8 plus b over x plus 2. And let's begin. Now we're going to multiply by that denominator, x minus 8, x plus 2, like so, right? On the left side, that's going to cancel out. We got 1 minus x. On the right-hand side, when we multiply here, these are going to cancel, and we got a times x plus 2. And then over here, we're going to multiply. These are going to cancel. We got b times x minus 8. So plus b times x minus 8. Great. Now we're going to choose some values to plug in for x. I'm going to choose negative 2 first. That's going to zero this out. Negative 2 minus 8 is negative 10. So we get negative 10b is equal to 1 minus negative 2, which is 3. Divide both sides by negative 10. b equals negative 3 over 10. Cool. Now we need to solve for a. And to do that, let's choose a different x value. Now I'm going to choose positive 8. That's going to zero this out. So that's nice. So 8 plus 2 is 10. So we got positive 10a equals 1 minus 8, which is negative 7. Divide both sides by 10. a equals negative 7/10. Great. Okay, now we're going to write out our final answer. And again, these guys are just chilling, right? So we got 7 over x plus 8 plus 5 over x minus 2. And now we can put the decomposition of this in these terms, right? So a is negative 7 over 10, and then we multiply by that denominator, x minus 8. And then b is negative 3 over 10, and then we got the x plus 2, like so. And that is how you do it. Done. So for this one, there's quite a bit of fraction decomposition we need to do, and we got to start by factoring these to the best of our ability. So in this first one, it's a difference of squares. We got x minus 4 times x plus 4. All right. For the next one, we've got, and you know what? I'm going to distribute that negative. I'm going to turn it into a plus and switch the signs of the numerators, right? It's like multiplying each by negative 1. 2x minus 1, and then we're going to factor this. What two numbers multiply to 8 and add to 6? That's going to be positive 2 and positive 4. And then here, again, let's distribute that negative. Let's make it a plus, and then we flip these guys, right? Positive 5 minus x. And then we can factor out an x there. So I'm going to break this up into 3 different basically situations. We're going to first decompose this, then this, then this. So this is going to be a lot of work. Let's start with that one. So we got 2x over x minus 4 times x plus 4. And that's going to equal a over x minus 4 plus b over x plus 4. All right. Now we're going to multiply by that denominator. We got x minus 4 times x plus 4. That's going to cancel that out when we multiply there. So we got 2x is equal to, we multiply this, these two are going to cancel, and we have a times x plus 4. And then when we multiply this term, these two are going to cancel. So then we've got b times the rest, b times x minus 4. Great. All right, now we're going to plug in values for x to solve for a and b. First, I'm going to plug in negative 4. That's going to cancel this out to solve for b. So b times negative 4 minus 4 is negative 8. b is equal to 2 times negative 4, which is negative 8. Divide by negative 8. And b is equal to 1. All right, now let's do the same thing to solve for a. We're going to plug in positive 4. That's going to cancel this out. And then we got 4 plus 4, which is 8. So we got 8a is equal to, I'm just swapping the sides, 2 times 4, which is 8. Divide both sides by 8, and we got a is equal to 1 as well. Next, let's decompose this one. So then we got 2x minus 1 over x plus 2 times x plus 4 is equal to a over x plus 2 plus b over x plus 4. Great. All right, so now we have a little bit more room. Again, multiply both sides by that denominator, x plus 2 times x plus 4. Okay, when I multiply this term, that's going to cancel out. Oh, by the way, sorry, instead of a, let's use c and d so we don't get so confused, right? Because it'll make it a little easier as we go back and fill in the entire answer. So we got c and d. So anyways, multiply by this, and for this term, it's going to just be 2x minus 1. And then we multiply against this guy, these are going to cancel out, and you got c times x plus 4. And then when you multiply against this term, these will cancel out, and then you have d times x plus 2. Okay, now we're going to choose some values for x to plug in. First, I'm going to plug in -4, canceling that out. -4 times 2 is -8 minus 1 is -9 is equal to -4 plus 2, which is -2d. Divide both sides by -2. d equals 9 over 2. Okay, now we're going to solve for c by plugging in -2. Okay, the reason why is because that's going to zero this out. So -2 times 2 is -4 minus 1 is -5. And -5 is equaling -2 plus 4, which is 2 times c. And then divide both sides by 2. C equals -5 halves. All right, so now we have A, we have B, we have C, we have D. And the last one we have to do is this one, 5 minus x over x times x minus 4. And to decompose this one, we've got E over x plus F over x minus 4. Okay, let's multiply everything by that denominator, x times x minus 4. And we multiply the left side, boom, that's gone. We got 5 minus x over here. Multiply against this term, the x's are going to cancel out. And we have e times x minus 4. And then we multiply against this term, right? These are going to cancel. And you've got plus f times x. Great. Now let's choose some nice values of x to solve for e and f. First, I'm going to plug in 4 for x. It's going to cancel this out. We got 4f is equal to 5 minus 4, which is 1, divided by 4, and f equals 1 over 4. Now we're going to solve for e, and to do that, I'm going to plug in 0, right? Because that's going to zero this out. 0 minus 4 is -4, so we got -4e is equal to 5 minus 0, which is 5. Divide both sides by -4, and we have e equals -5 over 4. Okay, so we got this, and we got this, and now let's move up. So we got a lot to write out. I'm going to kind of choose this spot and make a little bit of room here, all right? But we can still at least see the A, B, C, and D. We'll have to scroll down in a second. So A is 1, so we start off with 1 over x minus 4, plus B is also 1 over x plus 4. Then for C and D, we got -5 over, and then C, you know, the denominator is 2, so it's 2 times, what is that, x plus 2. And then we've got D is 9 over 2 plus, oh, need a parenthesis, plus 9 over 2 times, that's x plus 4. And then the last piece, we have 1, so E is -5 over 4. So we got -5 over, right, I'm looking at this, right, -5 over 4x. And then F is 1 over 4. So we got plus 1 over 4, and then times that x minus 4 in there. Okay, now I kind of cleared away a lot of the stuff. It's basically all of this, but you know, we can get some common denominators and simplify a little bit. For example, I see an x plus 4 here and here, but that one's just multiplied by 2. So I can likewise make this a common denominator if I multiply top and bottom by 2 and 2. Also with this x minus 4, there's a 4 there, so if I multiply this one by 4 over 4, I have another common denominator. All right, that's about the best we can do. Now let's combine everything. First, I have -5 over 4x, which can't combine with anything. Then I have the -5 over 2 times x plus 2. That can't combine with anything. Then I have the x plus 4 is 9 plus 2. That is positive 11 over 2 times x plus 4. And then last but not least, we have the 1 and the 4 over 4 times x minus 4. So you add those together, and we get 5 over 4 times x minus 4. And just a quick caveat, in the back of the book, they have a plus here, but I'm pretty sure that's a mistake. So this is how you do it. That is a long question, but that's the answer. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.